All right. So we were discussing dynamic multi-point VPNs, and I was saying it's a way that we can use to manage a case where we have multiple site-to-site VPNs, tunnels that needs to be created, right? So I was saying, create this, this, this. Right. Can check a pekunyorera, just a minute. Can I find some way? All right, let me use this. So I was saying, in a case security, I have my routers angle 1, 2, 3, 4. Then my routers angle I for anima side to side, which are static by the way. My settings, my configurations, and at this point, it allows link E, return E, could be static. So it's a connection between 1 and 2. Panapa can have another one, a connection between 1 and 3. Panapa, a connection between 1 and 4. That is a normal setup here, VPN without DM VPNs. All right. What DM VPN does, it allows my routers A to I, in this example, the central one in to act as a hub. Then I to act as my spoke. Hub Basararo now becomes more of a central device where my devices are 2, 3, 4. They send their settings to the hub. So for example, kuti my IP address, EIP address yakati, public IP address. Patinoita my settings, VPN, public IP address will be critical for that because we're just using that IP address to facilitate creation of tunnel here. So my devices 2, 3, and 4 must spoke, they send information now to the hub. So information yes in on that central device. Then in a case yekuti pamwe paroda communication between 2 and 3, instead of using my static VPNs that I create kuenda oku also ya up because of my shared settings atinenge taisa pakadaitwa communication between 2 and 3, central hub iri rinongo act as central device rinosendera this one kuti destination IP ya 3 ndiani, this one destination IP ya 2 ndiani. Then that allows for creation between tunnel iri dynamically without making use of bandwidth iri up kuenda oku nekudzoka oku. That's the idea around my DM VPN. So in a situation where you have my static VPNs, meaning ndikadaita connection between my VPNs angu anenge ari static. DM VPN
Sorry,
yes.
ndanzwisisa pamashandiro anoita nhingirini pasetup iyo yechihub and spoke iyo handiri,
Yeah.
but pansina kunyatsobata ka specific application yemashandiro azvinoita panhingi pamashita zvema-IP address something ipapo pane pandasara.
Right. So ukadatarisa like kana tiri kutaura kuti we are setting up VPN. Let's use simple one. Uona kuti chinge chiri kuitwa chii. So if we want to create a tunnel panapa, my configurations anongoitwa, it requires us to know kuti address, public IP address gateway kunokuichi, public IP address gateway kunokuichi. Then patinoisa configurations edu tongotaura kuti destination network yangu ndeishi, protocol randoda kushandisa IPsec. Then traffic yese painouya panapa inenge yakuzoti kana traffic if it is destined to this public IP address, then I have to encrypt using protocol rakati ndokunonzi kucreate a VPN kwacho. That's the idea behind creating my VPNs. So importance of knowing the destination network, ndeyekuti you create a tunnel depending nekuti destination network yako ichi, so that traffic yese inenge inoenda to that destination network will be encrypted from one VPN gateway. Saka ukaita situation yepanapa now, madestination anenge ari kuzikanwa ndeyemastatic panenge tacreata mastatic VPNs aya, static VPN iri, static VPN iri, but between these two devices they don't have a link riripo apa. Saka information yekuti vacreate a link iroro, they'll be getting it from the spoke basically. And I'm trying to simplify as much as I can. Zviri kumeka sense?
Alright, saka apa tiri kuti central device redu ndo rinenge rakurowa encryption dzacho yakava nti ringosenda like information yekuti yoencryptwa sei depending nekuti kuenda kupi.
Exactly. Yakada kufanana ne, it's more of the same concept ye zinoshandisa central device STP, root bridge. So device iro hub iro rakuita safacilitator kutaura kuti device 2 and 3 kuti mukwanise kuita connection, this is the necessary information that you need. Yopa public IP address, yopa the encryption yatoda kuita, then allows creation of a tunnel directly between 2 and 3 without using static VPNs anenge akacreatwa kuti 2 to 1 then 1 to 3 kind of a thing.
Ndapabata.
So that's the idea behind my dynamic multi-point VPNs, because kana tisina iwayo situation inoitika nayo ndeyekuti takuita static VPNs between 2 and 3 as well, because ndikati 1 2 3 ndikaisa 2 static yakadai so panapa ndakuda rimwe tunnel up, another static, but in this case I don't necessarily need a static iri, ndinoda a dynamic rekuti pakashewa information kubva kucentral device ndo patino create a tunnel, communication ikangopera tunnel iri rakutobva iri. That's the dynamic part. That's how bandwidth is being saved. That's how it's managing is much easier, because you don't have to create a static link rilipo panapa, static VPN I mean. I think it would have been proper kuti paitwa configurations of VPN, because ukaunderstand kuti chii chiri kunyatsoitika in terms of configurations, kuti parouter pacho tiri kuitei, you realize it's a very simple concept. Iconcept yekungoti traffic kana yasvika painterface panapa, if it's destined for network ish, encrypt using this type of encryption. I think tichaita SA what encrypt using rules I ndo inongonzi VPN yacho basically. Right, toenda pa IPsec VTI. So here is a case yakada kutofana ne dynamic dynamic multi-point VPN redu. Now in this case, instead of us having a VPN directly linked to our physical interfaces, so instead of having a VPN redirectly linked to virtual interface, physical interface panapa, we have a situation where we use my virtual interfaces. My virtual interfaces iwayo allow us an element yekuti scaling inoita much easier. So if I can summarize, it has the same advantages ne DMVPN. In terms of managing, it becomes easier. We are not configuring my static VPN using my physical interfaces of our gateways edu, firewall or router. In this case, to create my virtual interface. My virtual interface ndo achashandiswa to create my VPNs. That's basically it. So my visual interfaces, you can create multiple visual interfaces on the same device. So panapa, you can create multiple VTIs, meaning I can create multiple tunnels. But ukadoshandisa physical interface ish, it limits you to one. tunnel. I1 tunnel wrong or kushandisa. Excuse. So IPsec VTI interface, I think it's just a way you avoid that, not avoiding creating one tunnel to shine some visual interfaces in this case, because link a tunnel rako physical interface, you are limited. Kuti physical interface ari paruta rako mangani or ari VPN gateway rako ako mangani. So instead of using those physical interfaces, you use my virtual tunnel interfaces. That's the idea around this one. Then to end up service provider MPLS. Right. Today, service providers use MPLS in their core network. Traffic is forwarded through the backbone using labels. Traffic is secure because service provider customers cannot see each other's traffic. Right. So background MPLS, I think is very important. Although I won't go through it, I think I'll give you an assignment. Go through what MPLS is and the use of label switching instead of packet switching, which we ordinarily know. With MPLS, we have my service providers creating my VPNs, especially for my enterprises, making use of my labels instead of encryption. So traffic ye-network E inenge ine label yayo. Traffic ye-network E ine label yayo. Ma-labels kana akasiyana. It means users mono they cannot see traffic ekunoko. That's basically creating a sort of a private network. Instead of encryption and all, traffic inenge ine ma-label. Ma-label will determine who sees what. So traffic from different networks have different labels in general. That's how the type of VPN is formed. My labels here I could replace encryption basically. Then my type sema MPLS solutions here to layer 3. Layer 3 is a case where service provider acts as a router. Panapa, let's start simplifying it for understanding. Service provider acts as a router, meaning different networks, different enterprises, different labels. Per layer 2 MPLS, service provider not involved in routing, Panapa, act as a switch. So we have a multi-access network instead of different types of networks. So Panapa, if I can try to simplify, service provider Panapa, act as a router, meaning my networks they are segmented, different type of networks that inazo. So Panapa different networks Panapa. Panapa is the same network, same multi-access network, but different segments. Example, analog and ndingashandisa my VLANs, for example, same switched network, but my networks are different, segmentwa nema VLANs. So just in terms of understanding kuti kandichitaura nezvekuti layer 3 MPLS, I think it's a bit unfortunate if you don't understand the concept of MPLS that much. But if you want to understand the difference between layer 3 and layer 2, think of layer 3 router, routing, layer 2 switch, no routing. And basically that's it. That's the difference between layer 3 MPLS VPN. Then if you want to understand what's the difference between a service provider MPLS and the other type of VPNs, this one uses a label. The other ones, they use encryption. Different labels means different encryption. I cannot say that. Different labels, a bit difficult. I think we have to have a session to discuss MPLS nekudipisa about label switching, probably then understand the difference between layer 3 MPLS and layer 2 MPLS. Let's keep this one for another session probably. Titangire ku-MPLS instead of at the surface. Right, to end up IPsec, I think we've discussed IPsec already. A standard that defines how VPN can be secured. IPsec packets between source and destination provides essential security functions. Right, IPsec defines four fundamental security services. One, confidentiality. Who sees what? Uh, who has authority to see what? You can has no authority to see traffic here, you won't be able to see it. Confidentiality. Integrity, alteration. Traffic and sender from A to B should remain traffic and sender from A to B. I was saying ndikasendera ramunhu ego cash $100. Message inofana kusvika uko ndeyekuti ndasendera munhu ego cash $100. An attacker can intercept message ochinja kuti I'm sending 1,000 US dollars. Therefore, message yedu inenge isina integrity. So IPsec make sure we have confidentiality, we have integrity, authentication, who gets access to what. Then this one, DH, key exchange. Right, when we talk of key exchange, I think the other ones, these are not new concept, confidentiality, integrity, authentication. Then panapa pa key exchange up. It's a case yekuti kana tichida encryption between device A and B. Iyi ndo data rangu iri. Ndori encrypta ndichishandisa key iyi. Uyu kana achida decrypta uyu anofanira kuziva kuti key yangu ndeiyi. How do they know key yangu? So data rangu plus key ndo inonzi encryption. Kunoko uyu kuti adecrypte uyu anofanira kuziva kuti key ishi uyu. So there is need ye-exchanging ye-key yacho ipapo apa. How do we exchange that key? Key over exchanger is still secure. Someone intercepts, that's a problem. Zero time to decrypt the information yako. So this DH deals with how there's an element in my digital certificates and whatnot, which is a secure way of exchanging my keys edu. Key yoyo inotoitwa encryption yayo, yoitwa hashing yayo to create my digital signatures, to create a certificate, then to send a certificate. Kunoko pochizoitwa de-encryption, pochizoitwa de-encryption, otanga waona key wade-encrypt or waita reverse hash, oona key yako, then panozosvika data kubva kunoko ochizoshandisa key iyi to decrypt information yako. So the idea around this last part is secure key exchange ndeyekuti kana tichida encryption toshandisa key, saka key yacho ichasendwa sei to the receiving device, because the receiving device needs to know kuti key yatiri kushandisa ndeipi. Ndo panoshandiswa algorithm iri rapa DH. Yeah, IPsec tech. Here IPsec is not bound to any specific rules, easily integrate, open slots. I think what we are looking at here is just the type of algorithms that tinoshandisa. In the example, if you want to ensure a confidentiality, which algorithms can we use? Some algorithms are upper. DES, triple DES, these are just algorithms. I think at this level, you just have to know, kuti, for example, the type of algorithms that tinoshandisa for confidentiality, you have to be able to pick this. For authentication, MD5, SHA, I think pane SHA 1, 2, and 3 as well. Ndoma algorithms anoshandiswa for integrity wayo. Ukangoona MD5, I usually get question here a lot. Algorithm inoshandiswa kana ungonzi MD5, it ensures what? Answers integrity, confidentiality. So you just have to know, could this type of algorithm, it ensures which fundamental security service provide when IPsec. Authentication, PSK, RSA, pre-shared key. We have RSA as well. Then DH 1, 2, 3, 4, etc., etc. So on this one, it's just a general view of the type of algorithms that inazo for the fundamentals of IPsec services that inazo. Then at the top panel, the type of protocol that we are using. I think on the next slide. IPsec protocol encapsulation. Right. When we are configuring IPsec, choice encapsulation protocol is very important. Why? Because it allows us to detect functions, security functions that are available for us, but not ma SAs. So tine two I. So my SS is repairable. Let me see confidentiality. Wait, partner association yedu. So basically, tine two ma protocols that now AH and ESP. Ukashansa AH, if you use encapsulation AH, it means what you are catering for is only authentication and integrity. It means panapa confidentiality is not an issue panapa. Not an issue. So if information your sender does not require confidentiality, then the type of encapsulation you use AH. So an example, you're on a company. No. Let's use example a military. Military can share information yayo. Pamwe that information ndiye munhu wese arofana kunzwa that information. There is need authentication, yes. Kurakidza kuti military. There is need message yedu not to be altered. But there is need confidentiality. Hapana encryption network message yo, because everyone in the military is trying to receive that message. Everyone within the military is trying to receive that message. No confidentiality probably is required for that. It's a different scenario with header hero. If we use ESP, header hero, that one will provide for confidentiality. And that's the difference between AH and ESP. If you want to cater for confidentiality, then you use ESP. If you want to cater for without confidentiality, then you use AH. They are not used exclusively. At times, you can use both of them, both encapsulation methods in one network. Then to end up confidentiality. Right here, we are just defining what confidentiality is, encryption, message yedu the ish, key yedu the ish. Inonzi, what's the name for that? This is plain text. I think it's digest or something. There's a technical term for this message. Inonzi, what's the technical term for message again, encrypt? I'm forgetting that. I'm forgetting that one. But anyway, this one is just trying to show you the confidentiality. tinoshandisa key for encryption, then tosenda information yedu, then toshandisa key yedu iyoyo for decryption. That's how we get to see message yedu on the other end. Panga ndichitaura zvema-message keys ndezvekuti key yedu pairi kusendwa apapo ish inofanira kunge iri secured as well. How do we secure that key? Because key yedu iri kusecure message, but chii chiri kusecure key yedu iyoyo ndopanopinda DH. The type of protocols zatinazo, we have DES, triple DES, AES. I think key panapa is identifying, understanding the strength yema-keys edu, as well as the type of algorithm that we kushandisa. Ndo zvinodetermine kuti how confidential will be our communication. So ma-keys and ma-bits akawanda, logic, it means ane strength yakawanda. It means example yekuti unoita brute force attack, the number of possible outcomes that unenge unadzo dzinenge dzakawanda stereki. Therefore it will take you more time kuti ukwanise kucracka password, etc, etc. I think here is just a case of recognizing kuti confidentiality chi, the type of algorithms dzatinoshandisa and the app, what defines a strong key, what defines a very good algorithm. Then same thing for integrity, MD5 nature. The more the key, the stronger the hashing is. I did this one. Integrity, it's more of, I think encryption, we know, unotora information, oita chibende, that's you using the key, message yawasenda, yobiringishwa, then you have another message which requires the key kuti uinzwisise, generalizing. Integrity, it's more a case yekuti information iri kubva kunoko inoperforma inonzi hashing yobudisa a-value, then painosvika kuna b uko information iyo inoitwa hashing as well, pobudisa value yabuditswa kunoko nevalue yabuditswa kunoko dzinofanira kufanana. Dzikangosiyana chete, it means panga panosendwa message apa it has been altered. I think we explained this a little bit pa error detection inoitwa pa layer 2 FCS inoshandisa CRC what. That's a form of hashing inenge iriitwa papaya, so that you ensure integrity yemessage yako. So that's the idea around hashing iyo. The higher the key yauri kushandisa, the more difficult it is to finding this value, because munhu akangoziva value iyi kuti ichii ndo zvinoita kuti anokwanisa kuchinja message knowing kuti value after hashing yako ichii. That's integrity. Authentication, it's more with telling the system who are you. We have two methods ziri kushanda apo, PSK, pre-shared key, then we have RSA. RSA makes use of my digital certificates. Pre-shared key, it's more of kana ndichidaita login, how do I put this? Kana ndichidaita login, system A and B kunoku ndokurodaitwa login, kunoku ndokune system yelogin. Device iyi irinosenda ma-details aro kunoko kunenge kune database ritoriko rine ma-details achazosendwa kunoko. So ma-details aya, ma-passwords zvese zviri kubva kunoko, they are already shared 10 minutes in this database, atoriko kudhara, they are pre-shared already. So iwo paunonzongoma enter is just a way of verifying kuti ndizvo here zvaiswa, password yaiswa, username yaiswa ndiyo here. Then basically that's how you get authenticated. These are ways the authentication yedu. And CCNA doesn't require us to go deep zvakati nyanyei. But if you want to do network security, for example, I think you're going to DPS. At this level, you just have to know kuti ma-algorithms anoshandiswa for authentication, the app RSA, PSK. The last one, ion key exchanger. Those are algorithms anoshandiswa for sharing a secret key over an insecure channel. I think I saw, I think I saw, right, I think I saw a diagram which was trying to explain. Let me go through it. I'm not on about PowerPoint now. Right. Uh, Go through understanding the neuroscience. Convert. Uh, just a minute. I want to move this. Not depends. Right. There is a need of understanding the technical terms for information here. Is it go through my process encryption, hashing, and all? You can see kuna information yedu iyo irapo iyo. Ne key yedu, what does it give? Apa ndo pane information after encryption. There's a technical term for that. I might be confusing network security ne this level. Let me see kana wakazitaura. Private encryption. Yeah, I might simplify things for now. For me, not for you. Right, go through a little bit of research up. And then I'll revisit network security angle a little bit. So that DPC is a very interesting concept actually. So that DPC process yes defining good my digital signatures, my digital certificates, defining sharing ema keys yacho. Kuti how are the keys secured? Because it's also true secure information in using that key. But is that key secured? How do we then secure that key? Then the reverse process gonna create decryption, yeah, hashing. How do that process happen basically? And how are the protocols interact, the algorithms interacting with each other? I think I'll prepare a separate session to focus mainly on my digital signatures and my digital certificates. I can see Panapa are not DPs for that much, but it becomes very difficult now explaining them if they are touching on the surface like this. But otherwise, I think we understand what a VPN is. Talks about site to site, talks about remote access, talks about IPsec key, talks about SSL key, talks about the type of algorithms or chance for confidentiality, integrity, authentication, then sharing of keys. Talks about MPLS, kuti in a layer 2, in a layer 3. What else? Basically, I think that's it for this level. Go through my questions. Then you can ask inbox if you have any other specific questions. I think we're good for this one.
Yeah.